Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imran bin Azni. For our group project, we've chosen question number 2, properties of relation. We created a Java program that allows users to enter a set of elements and a relation on that set. The program then checks whether the relation is reflexive if every element is related to itself, symmetric if the direction of each pair is reversible, and transitive if indirect connections are preserved across the elements. Not only does it identify properties, but it can also generate reflexive, symmetric, and transitive closure if any of those properties are missing. In discrete mathematics, these properties are fundamental when analyzing binary relations. Our goal was to take these theoretical concepts and turn them into something more practical. An interactive tool that helps users understand the behavior of relations more clearly.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ishazwan and today I will be explaining the code of our program. So a bit introduction of our program. The name of our program is a relation analyzer and we use Java as our programming language and the compiler that we use is IntelliJ. And the input and the output will be given from the console. Let's say the user will be prompted in the console and they will enter the input from the console and their output will be also shown in the console. So let's see the code. So here we have the welcome message. So next the user will be prompted to enter the number of elements in the set. This will get the distinct number of element. So and here, so the user will also needed to enter the elements of the set. So let's say you have an element with number or with words or string. So let's say you have apple, mango, and papaya. However, it is hard to process if the element was called string, not a number. So we use hash map to convert the element from the string to an integer as their ID or their ID in the map. Let's say you have apple, mango, and papaya. In the hash map, they will be stored as 1, 2, and 3. In our program, we mostly use for loop because it will iterate through our array. So next, the user need to enter the number of ordered pairs in the relation. In a relation, there are several pairs that can be determined, and we need to determine whether the relation are symmetric, transitive, or reflexive. So, first we need to we store the relation in a 2D array. So the num pairs or the row will be determined by the user, but the column will be constant too because it is a pair. So the user will be needed to enter the element A, the first column, and element B, the second column. So here it will be stored in 0 and 1. The first column and the second column, element A and element B. If the element does not exist in the set in here, the set, so the user will need to enter the element again and valid input will be prompted. The user need to make sure they use the correct element inside the relation. So here we initialize to reflexive, whether is it reflexive, is it symmetric, or is it transitive. We use boolean data type because boolean will return the value true or false. So let's say if it is reflexive, is it true? It is true. So the system will print reflexive. However, if it's false, the system will print not reflexive, and it is same for all of the condition. And here we call the function format relation to print the closure of the relation. And this is the thank you message. So next, to print the here to print the set of element or the original relation, we need to use the format relation function, because in a full relation there are several different type of string. We have curly bracket, bracket and comma. It is hard to use a normal for loop, so we need to use string builder here. As you can see, string builder append will join the string, and it will be starting with an open curly bracket and will be ending with a closing curly bracket. So in the curly bracket, it will be starting with an open bracket and will be ending with an open bracket. But in the bracket, there will be a comma in the inside, and the string will get the element of the pair A and B here. So it will print the relation with the perfect format. So here, first we need to check if the relation is reflexive, and the function here is the is reflexive. We call two types, two data, which is the relation array and the set size. Why we need to call the set size? Because to make sure all pair of set elements are available in our relation. Let's say we have apple, mango, and papaya. However, in the relation, you only use apple and mango, and there is no papaya. So it will return the value to false. However, if there is there is a there is the same A and A, the relation will be found and the value will be true. So next we need to check if the relation is symmetric. Symmetric is when the relation AB and BA is available in the relation. So we need to initialize the first element to A and the second element to B. If element A equal to B and element B equal to A, so it will be found the symmetric pair and the value will be true. However, if it not found, the value will be false. And lastly, to check if the relation is transitive, we need to check if A, B, and C, D. Next, we need to make sure B and C is equal. So here, as you can see, if B and C is equal, so the relation will check whether A and D are available in our relation. So here, the for loop will iterate through all of our iteration and check whether A and D are available in our relation array. If the value is true, so it will found the transitive pair value will be true and the value will be written true. So next, to compute the reflexive closure, we need to call the same type, which is the array relation array and the set size. So as you can see here, the relation, the this line of code will act like a basket. It will go to see what what are the content of our hash map. So hash set doesn't allow any duplication. It act like a basket to fill any void or any element that are not used in our relation. So here, as you can see, you will add the I, comma I. I've explained before, apple, mango, and papaya are saved as 1, 2, 3. If one apple is used, then it will print apple, apple, comma apple. 2, comma 2 will be print mango, comma mango. And 3, comma 3 will be print papaya, comma papaya. And it will happen here, where the string change back to a 2D integer array. It was also the same with the symmetric closure, where the hash set will not allow any duplication, and it will add the symmetric pair B A. It will check first whether A and B exist. But if B and A does not exist, it will add the B and A. As you can see, pair 0 and pair 1 will be printed, and pair 1 comma pair 0 will be will be printed. And this is where the printing process uh, will be done. And lastly, the transitive closure. This is a bit hard, so we use Warshall algorithm. Warshall algorithm will check if a path can be formed through the middle points. As you know, to to check if the relation is transitive, we need to make sure AB and BC A and D exist. So we need to make sure B is the same. So first, for INTK, this is the middle path. Let's say, can I go through to A and C by going to through B? So the K will be act as the middle point, the B in our relation. So that if that pair exists, it will add the element or the pair A and D into our closure. So here it will add the closure I and J. As you can see, K act as the middle point or the middle. I and J act as A and D. So it will add the closure A and D. And this is where the breaking process happen. So that is the relation analyzer code that we use for our program. That's all from me. Thank you.
Hello dan Assalamualaikum. Nama saya Muhammad Nazrul Syamil bin Nizam and I will be presenting the demonstration for this program. Okay, first we'll be running the code, the program. All right. The program will print out the welcome to relation analyzer on the console. So first the welcome message, and then it will prompt the user to enter the number of elements in the set. In this case, we will choose a set size of 3 and the elements, and then it will prompt for the user to input each element's value. In this case, we're going to use 1, 2, and 3. So afterwards, it will ask the user to input the number of ordered pairs in the relation. We will choose 4. So, and then we have to choose the relation 1, 1, 2, 2, 2, 3, 3, 3. So after that is completed, the program will compute, and then first it will display the set that we have decided, which is 1, 2, 3, which is the elements in this set size of 3, and then the original relation, because we have set it as 4, so there's only 4, 1, 1, 2, 2, 2, 3, 3, 3, and then afterwards it will determine, the program will determine whether the set is reflective, symmetric, and transitive. So in this case, the elements in the set is said to be reflective and transitive. But it is not symmetric. And then it will show the closures for the relation properties. The first being reflexive closure. This is the reflexive properties. 1, 1, 2, 2, 2, 3, 2, 3. Symmetric closure. 1, 1, 2, 2, 2, 3, 3, 2, 3, 3. And transitive closure 1 1 2 2 2 3 3 3. And then after the operation is done, it will show the ending message, which is thank you for using relation analyzer. That is all. So next we'll be moving on to the next presenter.
In conclusion, the successful development of this program was achieved through the collaborative efforts of every team member. Everyone played a vital role and made meaningful contributions toward the completion of this project. We managed to complete the project within the allocated time. The program is user-friendly and highly beneficial for students as it provides accurate results based on the specified properties of relations. It serves as an effective educational tool for those studying relation properties, offering them a clearer understanding of the topic. By displaying correct outputs, the program helps improve students' comprehensions of these concepts. Throughout the course of this project, we gain numerous valuable insights and lessons. Firstly, our knowledge of relation properties deepened significantly as we worked on this project. We became proficient at distinguishing between reflexive, transitive, and symmetric relations. In addition, we explored and understood the concept of equivalence relations, which are binary relations that satisfy all three conditions: reflexivity, symmetry, and transitivity. Secondly, we develop essential skills in creating a program using the Java programming language. This project proved to be an excellent chance to apply and strengthen our programming skills. We also learned how to manage our time effectively, ensuring we could handle our responsibilities for this project alongside other academic commitments such as tests and assignments. Overall, this project was highly valuable learning experience that allowed us to deepen our understanding of relation properties, enhance our programming skills, and cultivate patience and effective time management.